Hi guys, welcome to my YouTube channel. This is G Prime Online Tutorials. It's a platform that is designed to help you with your academics challenges. You can do as well by liking this video and sharing it with your friends. It's going to be of help to them. So today we are going to be considering a topic in telecommunication engineering. I tagged the topic to be amplitude modulation. So I hope that you're going to enjoy the ride with me. Thank you very much. So what is modulation? Modulation is the act of superimposing lower frequency on higher frequency signal. And then what is amplitude modulation? Amplitude modulation is a system of modulation in which the amplitude of the carrier signal is made proportional to the instantaneous amplitude of the modulating voltage. So I tagged the topic to be amplitude modulation. So we say, what is amplitude modulation? It's a system of modulation in which the amplitude of the carrier signal. So this is the amplitude of the carrier signal. Small vc is equal to big vc sine omega ct. I tag this to be my equation 1, and then small vm is equal to big vm sine omega mt as my equation 2. We said it's a system of modulation in which the amplitude of the carrier signal, this is the amplitude of the carrier signal, is made proportional to the instantaneous amplitude of the modulating voltage, while this is the amplitude of the modulating voltage. Now let's define each term here. Now the small vc is the carrier voltage. The small vm is the modulating voltage. While the big vm is the amplitude of the modulating voltage, while the big vc is the amplitude of the carrier signal. Having defined this term, the next thing we are going to be considering in the derivation of amplitude modulation is the modulating index. This is what we call the modulating index, and the modulating index is just the ratio of the amplitude of the modulating signal to that of the carrier signal. Modulating index m is given by big Vm all over big Vc. I hope we are going to be knowing and understanding the differences with the V. Please take note of the V. We have the big V and the small v. In the modulating index, we are considering the big V's and the big C's. So after defining our modulating index, we can make big Vm the subject of formula because we are going to be making use of it in the later times. Big Vm is equal to what? Divide both sides by 1, cross multiply. Vm times 1 is Vm equal to Vc times m is mVc. Let's tag this our equation 4. So having defined our modulating index, the next thing we are going to consider is the amplitude modulating voltage, and the amplitude modulating voltage is given by A is equal to big Vc plus small Vm. Please take note of the sizes of the big and the small. This is our equation 5. That's our amplitude of the modulating voltage. So now we know that from equation 2, we know that our small Vm is big Vm sine omega t. Now substituting equation 2 into equation 5, we'll have it as what? A is now equal to big Vc plus, instead of small Vm, we already know that our small Vm is given by big Vm sine omega mt. Now substituting this into this small Vm, we'll have it as what do we have now? big Vm sine omega mt. Let's tag this our equation 6. I hope we are understanding and following. Now, from our modulating index, we know that our Vm, big Vm, is equal to MVC. If we are following, we explained this earlier. Our big Vm is equal to MVC. Now, substituting this Vm into this equation now, wherever you see a Vm, you can substitute MVC now. Let's substitute it together. Our A is equal to big VC plus, instead of Vm, we have what? MVC sine omega mt. This is our equation 7. Then this is what we know. So now, considering this equation, you can see there are two similar VC and VC in this two side of the right hand side of the equation. So you can factor one of the VC. If I factor it out, I will have it as A is equal to VC open bracket 1, because if I multiply VC by 1, it's going to give me back a VC. Then 1 plus, instead of VC is gone out, I'll be left with what? M sine omega mt. This is my equation 8. I hope you are not getting bored with the equations. So let's continue now. This is our equation 8. So from our equation 8, there's another thing that is known as what? The instantaneous voltage of the amplitude wave. The instantaneous voltage of the amplitude wave is given by this equation that I'm about to write down. V is equal to A sine theta. Now this A is the amplitude modulated voltage that we've gotten here. That's what we are going to be substituting for this A. While this theta, I'm going to define this theta right now. Theta is given by omega ct. So now we can substitute these variables. We know that our V will now be equal to, instead of this A, we said we are going to substitute equation 8 as our A, which is going to be VC into 1 plus M sine omega mt close bracket. That's our A. Now we've substituted our A. So this is the first side of the equation that has A, while now the sine theta, we already defined our theta to be what? Omega sine omega ct. So this side of the equation is going to be included here as sine. Instead of theta, we'll have it as what? Omega ct. And then we can label this to be our equation 9. So now from this equation, we have two identities multiplying themselves. You know, from our trig identity, if you have sine x multiplying sine y, we'll have it as 1 all over 2 cos open bracket x minus y close bracket minus open bracket